Okay, I hope the screen is visible.
Yes, sir.
Yes, sir. Yes, sir. It's visible.
Okay, we'll continue here. These were the parameters from the previous slide, that is the unfolded part, that is U, V, and W. Those were the parameters. Based on those parameters, what we did, we unfolded it, and the internal structure you can see for an each recurrent layer, and then this data will be passed on to the feed forward layer. Now, feed forward will be the next iterations output as y of t plus 3. And the previous is the feedback loop. What you saw here, this is nothing but the feedback loop. This arrow represents here. Now, the current state information which will be stored in a particular memory, the current session going on, and what output will be getting. Again, you need to update it for the next iteration, because the output of the current iteration will be stored in your short-term memory, right? So that has to be again remembered as a second part of your memory. So there are some limitations for RNN working principle also, that what limit of amount of data you can save. Right now, after doing this, we need to focus on some kind of activation functions, right? Because a network here can be unfolded k times steps. You can take it for n number of steps to get the output for k plus 1 steps. So for using any kind of activation functions, for here we'll be going for 3 different type of activation functions. We'll get through it. Now this is what we get, the internal function of f for a particular function, activation function. Now, after applying these functions, we may get through feed forward, back propagation, LSTMs, GRUs, or any other, you can say bidirectional RNNs also, right? So in this here, this is the stated formula, how the iterations will be going on, unfolded internally for a recurrent neural networks. Now remember, this is a dot product over here. You may see here, we have calculated the common products over here, and then got a dot product. This will be internally done. Nowhere computation process takes into consideration what kind of inputs being processed. There's no static input also here. Based on the weight balancing of your inputs to the current weights, and based on your previous data, the hidden state, the hidden layer cells will be executing and giving the output. Now, remember here, O is nothing but the output state, I is the input state, and we have parameters as U, V, and W, which states the current transformation, the previous state, and the computed internal states. These are the activation functions. I think you might have heard of these. You might have used this for your visualization concepts, right? So these are activation functions which are being used for recurrent neural networks. There's a advanced concept called as a hyperparameter tuning. Traditionally, when we were used to learn deep neural networks, we had to use these functions as sigmoid, tanh, and ReLU functions. But hyperparameter, the advanced can say technique used in RNNs to resolve what kind of activation function for a particular RNN network, will help to improvise it for the purpose of optimization, which activation function will ignite well, so that my current neural network will be more optimized compared to my different algorithm, not the current iteration, right? Now, all these three will be taken as a parameter by the hyperparameter. All will be tested, compared with each other, and then try to analyze based on the current states, your previous state data. After analyzing, which is the best activation function and what algorithm should be applied over here. Now, let's compare this. Now, if you see, this is how the feed forward works, and this is how your recurrent neural network works, right? Now these are the few activation functions. You can see the way it is. This will be based on a threshold of 0 to 1. This you might have used in logistic regressions, wherein the categories are where the threshold is set to a certain ratio, and above that ratio, if you get a value, you have a categorized class, or if there's a point below the value, you have a special categorized class. Then tan h functions, we have different functions where we have ReLU function. Either the values, all values are 0, or they are up to a certain level, wherever the threshold you decide. In this, you can see it is up to 10. So my maximum threshold is of 10 or minimum is of 0, right? So that kind of activation functions which reflect some drastic change in either of the category, right? Those are nothing but the activation functions which lets you trigger to balance your weights in the neural networks. Now there are few comparisons where we talk about this feed forward networks and the RNNs. RNNs are very much popular, right? Because RNN here are mostly used for sequencing of data, right? The data nowadays, if you think of any on any production server, the data is never offline. The model I compiled for this instance will be older when the data comes for the new upcoming data, right? So it is always, you can say, in an processing manner, it always had to parse the sequential data so that your algorithms will be more, you can say, accurate and more precise, because the data which you are going to present will be uh, used for the market analysis, right? So these recurrent networks very much helps us to predict these kind of values. There are many advantages also. Also, there are some, you can say, limitations of using this RNNs. We'll see those. Now, if I want to train a model, there's a pseudo code written for this. First, initial repeat till the stopping criteria is met. That is, if you define some kind of threshold to get a value, suppose I'm having a sentence as the cat is drinking dash. Now, there are many possible words with respect to natural language processing, that the last word, missing word, can be predicted anything, as the cat might be drinking water, milk, or something else. Any word could be perfectly fitted. But if I have my previous observations in my cell, in my RNN cell, then what should be the criteria? What does fundamentally a cat drinks? So based on these predictions, what I need to do is, firstly, I have to set all to 0, right? That is my initial stage, the first unfolding step. Now I have to repeat the stages from N to K. In this way, the moment I start my iteration, that iteration, first iteration, when it is in processing mode, it has 0 value and it starts spreading something that is called as the forward propagation. It lets your network to unfold into some K steps, right? And those computation steps are called as H and Y. Now, there will be some error. Tomorrow we are going to see an example how the loss is reduced and the accuracy is increased, right? The loss will be reducing and going towards 0, and the accuracy will be going towards increasing towards 1, right? So in this way, this is the smallest algorithm for a single step of training of an RNN. This will be in a continuous loop. I have compiled one sample execution program for you. It is pre-compiled. I have taken only 10 epochs to run that input and to process it. So it took more than half an hour. So I pre-compiled it, and we'll be seeing that example when we cover up all these steps. Now there are many different, you can say, RNN. As I gave you an example that the cat is drinking dash. Now there might be multiple outputs to be predicted, right? Even if the cat word is missing as a noun, the dash is drinking dash. So there are multiple now. Now, if there are multiple keywords missing and we want to go for, you can say multivariate analysis, right? And in real time, there's no univariate analysis. There are always multi parameters where there are many things dependent on these parameters. So based on this RNN, there are different types of RNN. RNN basically will have these number of types, as in one-to-one, many-to-one, many-to-many, and one-to-many. Now, how these one-to-one and many-to-many runs, we'll see that. See, in one-to-one, we have x of t and y of t, right? So this is called as a plain neural network. One input going through one hidden layer and one output. Now, this in any scenario, any kind of scenario will not be an ideal situation. Okay? Just for understanding purpose, the types of RNN for a single particular layer will be one to one, called as plain neural network. So it deals with a fixed size of input to the fixed size of output, right? Where what we have is the independent of previous information. Simple example, what we can see is used for pattern analysis or image classification, right? One to one. If this is the image, show me the output, right? It does not have different patterns. So image classification. Then many to one. Now here it takes a sequence of information x of t plus 1, x of t plus 2, and so on. Then it forwards it data to the next layer after computation with the previous state, with the current state. Now these data are being forwarded to the next layer and so on. So it is many to one to predict only one output. Now here it takes a sequence of information as input of data and outputs a fixed size, only one output, right? For example, if you're going to see any kind of sentiment analysis where any sentence is being classified as expressing the sentiments in terms of positive or negative, right? Whether the person is angry or not, right? There are not multiple expressions here. There are not multiple sentiments. If I want to find out by looking at the pattern of an image of a face recognized data set, whether it is angry or not, only classified as yes or no, based on that sentiment analysis. So this part can be considered as one to many. Now we have many to many. Now this is an actual, you can say, real-time example wherein this takes a sequence of information. So multiple parameters, multiple cells are being used here for fetching the previous information, storing in the current information, and then moving forward for the output. So a sequence of information is taken here as an input and processes the recurrently outputs as a sequence of data. So there will be multiple outputs also, right? If you remember, this concept is much more similar to clustering part. Clustering will not give you an exact output. Compared to your traditional neural networks, there is one input, there's some processing done, and then an output will be given. So for particular linear regression, you get an integer value only. For logistic regression, you get a class one, right? As in a classification. For categorical, you get multiple clusters. Depending on those clusters, you need to identify which will be the best fit cluster and you need to focus on that. In same way, in many to many, sequence of information as input is taken, processed for the recurrently outputs, and given a sequence of data as an output, right? Wherein you can see for this example, machine translation is used where the RNNs, ready model RNNs, for any sentence in English and then outputs this sentence in any other language, right? So machine translation for Google Translate. This is many to many. The sentence is the same, x of t plus 1. I want that can say sequence of sentence to be translated in multiple different languages. The other is one to many. Now it deals with a fixed size of information as only x of t is present here, same as of one to one, but the fixed size of information of input will be fixed, but it will be giving you a sequence of data as an output, right? Such as I can say, for example, image captioning, which takes image as an input and outputs a sentence of words. Now, if I have a picture of a dog roaming in the park, right? The moment I say park, there are many things apart from only dog where I can caption it, right? There might be a bench, there might be grass, there might be people jogging over there might be children playing in the park, there might be a lake, there might be clouds, sky, trees, right? So there are lots of captions wherein these words together will describe the entire image, right? The image is only one, but with these different patterns mapping, I can form a sentence that what does this image describes, right? So this is how the actual, you can say, RNN works with these different types. Now, as I said, there are many advantages and disadvantages. Now here, let's list out the advantages so that from theoretical point of view, you may also come to a conclusion for getting the notes. So it has the ability to handle sequence data. As I'm saying that it is always applicable for time series data. So sequential data is very good type of data for RNNs. It has the ability to handle input of varying lengths, right? So in sequential data, there's nowhere you can say that the data will be in a fixed size or the same size, right? It will be, you can say, just in a random or varying lengths, right? Now, the most best advantage of RNN that it has the ability to store, or you can say, or to memorize the previous information, right? Whatever the historical information is, it has the ability to store into the RNN cell. Now, additional computation processes are going on adding, right? In traditional neural networks, we did not add any kind of cell information which will be stored there. Here we have extra cell which stores our previous memory store data to process it into your current state going on. So that computation part will be added. That added part will somewhere get your computation process slow, right? Now, depending on the network, which does not take into account your future input decisions, that will be always as a disadvantage for your RNNs, because currently for RNNs, we are using only the past information. Now, there's a problem called as vanishing gradient problem. There are two types we are going to see in this further point. Vanishing gradient problem, where the gradients used to compute the weight which is being updated may get very close to zero. Then the moment the gradient reaches to zero, the learning rate of your model of your neural networks goes to zero. It tends to zero. So preventing that network from leaving the new weights is nothing but the vanishing gradient problem. The moment you keep learning, your algorithm or your neural networks is being updated and is more optimized. The moment it reaches its learning rate as zero, it has nothing to learn. It has achieved 100% and it will remain stagnant, right? So this is the, you can say, disadvantage of using RNN.